Hello, everyone. My name is Sergey Sokolenko. I'm a product manager in the Google Cloud. Today with me I have Christopher Crosby, one of my PM colleagues, and Ravi Upreti from Qubit. And today we're going to talk about data processing options at GCP, Hadoop, Spark, and Dataflow. So the session today will be quite simple. We're going to give you an overview of the options you have. We're going to give some recommendations on what to choose. We're going to do deep dives into Dataflow and Dataproc. And then we're going to ask Ravi to come up and tell us the story of Qubit and how they use Dataflow and Dataproc. So let's get started. Data processing in the cloud, Google Cloud, is part of a larger data analytics offering set. Starting with data ingestion, you have access to Cloud PubSub, which is our messaging solution for streaming events. If you need to move structured or unstructured data to the Google Cloud, you can use the data transfer service. And if you need to connect your IoT devices, Cloud IoT Core is the solution for that. Now, once you ingest the data, you have now options to process it. And what are the options? If you're building a streaming solution, if you prefer accessing a state-of-the-art streaming framework such as Apache Beam, then Cloud Dataflow provides a managed service that unifies batch and stream processing. If you're coming from the Hadoop and Spark world, would like to continue using these tools, have an investment in a skill set like these tools, like Spark Streaming, then Cloud Dataproc offers a managed service, and that's a great choice. We also have a service called Cloud Data Prep. It's a visual UI tool for data wrangling. It's based on Cloud Dataflow underneath. It runs Dataflow jobs when data needs to be crunched. But to you, as the end user, it's exposed through a user interface. You don't have to do any coding. Now, once you ingest it and process data, you have to store it somewhere. So where do you store it? You have two options. You can store it in BigQuery, our cloud data warehousing solution. Or you can store it in the Google Cloud Storage if you're building a data lake. Once you stored your data, you have access to yet more advanced analytics products. For example, you can run predictions using Cloud ML Engine, or you can visualize your data using Cloud or Google Data Studio. You can also do full-scale, full-blown TensorFlow implementations and run them in self-managed mode or with Kubeflow. Or you can do your spreadsheets using Google Sheets. Combining all of this and kind of binding this together in a end-to-end solution, we have Cloud Composer, which is a managed Airflow implementation, managed Airflow service, which allows you to put all of these pieces together in a working end-to-end workflow. Now, how do you choose these options? Specifically for data processing, there's a very simple set of rules. If you're modernizing your data warehouse, if you prefer the ELT paradigm where you extract, load, and transform, and do the transforms, the processing inside of a data warehouse, then BigQuery is the solution that you should pick because it gives you rich SQL. You can write your SQL statements, SQL scripts, solve the problem that way. If you're building a streaming solution, if you want state-of-the-art streaming, unification with batch, exposure to Apache Beam, then Cloud Dataflow is the best managed service for you. If you prefer Hadoop and Spark, if you like Spark streaming, if you have existing investments into Spark and Hadoop, then Cloud Dataproc is a great way to run open source software in the Google Cloud. Now let's do a deep dive into Dataflow, starting with Dataflow. But before I do the deep dive, let me explain the differences between Beam and Dataflow. Several years ago, Google has open sourced the Cloud Dataflow SDK, and it became a top-level Apache project. In 2018, last year, at the end of the year, the Apache Software Foundation shared a couple of stats about all of their projects. And it turns out that Apache Beam is now the top project, or was in 2018 the top project by the dev list activity. It was the top 3 project by commit activity. So there's a lot of excitement and developments happening in the Apache Beam world. Why? Well, users like the fact that it provides a simple and unified batch and streaming API. You don't have to use different tool sets for batch and streaming. You can use one set of tools, one API. And portability, that's another big selling factor for Apache Beam, or big benefit of Apache Beam. Portability across runners. For example, you can write your Apache Beam pipeline and run it in the Google Cloud on Dataflow, or you can run it on Apache Flink, either in a different cloud or on premises. In addition to the runner portability, Beam also envisions portability across languages. So imagine a pipeline that uses some I/O connectors written in Java and some data transformations written by another team in Python, and perhaps yet another set of transformations written by yet another team at your company written in Go. It's pretty powerful if you're able to combine all of these components together. Now, Cloud Dataflow uses Apache Beam as its only SDK. This is the SDK that Cloud Dataflow is offering to its customers. It's a serverless, fully managed data processing option in the Google Cloud. Together with Cloud PubSub and with Beam, Dataflow offers exactly once streaming semantics. What does it mean? It means your messages get processed only once. Dataflow takes care of error handling and data deduplication. We also optimize used resources, not just resources, but also time that is spent on processing your resources. I'm going to explain a little bit later how the optimizations are working. And lastly, Dataflow offers separation of state storage and compute. And this separation allows us to scale the different components of your pipeline, the place where the state is stored, the place where the calculations are done. We are able to scale them at different rates, which improves our auto-scaling behavior. So let me talk a little bit about the vision behind Beam. And I'll use an example of a typical transformation, summation of values based on keys. So if you want to do a group by and sum all the elements by keys, it's a very typical operation. The vision of Beam is to offer a variety of such operations, not just sums. Summation is just a simple example, but all of the APIs should be available across different languages. The languages that are supported today include Java, Python. We have an experimental Go SDK, and we also Beam supports Go. When sometimes I say we, I sometimes mean Beam, and sometimes mean Dataflow. It's because a lot of folks who are working on Beam are also coming from Google. But we have a large community of non-Googlers contributing to Beam. Actually, the majority of people working on Beam is, at this point, non-Googlers. So in addition to this language portability, the other part of the vision for Beam is the ability to run in different environments. Imagine you wrote a pipeline, and you decided to run it today in the Google Cloud on Cloud Dataflow. And next day you decide, well, I could actually use locality, and I could do some data processing close to my data. So why don't I run my pipeline close to the data in my on-premises environment using a Flink cluster? That's pretty powerful. There's a variety of different runners being developed right now. Flink and Cloud Dataflow are the closest to, are the ones I would use in production. There are other environments or other runners that are being developed today. Apache Samsa is another one that is pretty close to being used in serious environments. There's work being done on the Spark runner and other runners as well. So now that we understood the vision behind Beam, let's talk about Dataflow. Lots of our customers like the fact that they don't have to understand this diagram. For them, Dataflow is a black box. It connects sources and sinks. What happens under the hood doesn't matter. For those of you who actually do want to understand what's going on, let me just explain what's happening in this black box. First of all, Dataflow takes care of resource management. What do I do? What do I mean by this? I mean creating resources, storage resources, and compute resources. These are the boxes in the middle of the diagram. And scaling them up and down separately, depending on how much data I have remaining that needs to be processed, and based on the parallelization capabilities of this data. Some data is more parallelizable for processing than other data. And if we encounter a data set that is easily parallelizable, we will create lots of resources that will crunch through your data very quickly. It will actually save you money and time for processing. So the other things that Dataflow does is, I already mentioned, dividing data sets. That's the work scheduling piece and dynamic work rebalancing piece. So we always keep track of the small pieces of bits of data that we have to yet to process. We assign them to processing nodes, We tracked how fast the work is being done. If we can improve the time execution, we will create new workers and assign the data to them. This way, saving you resources and execution time. We also do some mundane things like logging and monitoring. And it turns out monitoring is not that mundane. Some of the improvements that we've made over the past 3 months were actually about improving monitoring capabilities. Let's talk about what's new. Everything here was released or has been launched over the past 3 to 4 months. So you're looking at pretty fresh stuff. We are continuing investing in our streaming capabilities. We would like to be the best-in-class streaming solution. One of the things we launched recently was the exposure of 2 central metrics for streaming pipelines: system latency and data freshness. Freshness in other parts is called watermarks. So we are exposing them now in your job details page right there. It's visible to you. You don't have to go to Stackdriver to get these metrics. And in addition to seeing these statistics, you can also create alerts based on predefined thresholds. We released a streaming support in the Python SDK, and we worked with the Beam community on creating a production quality Beam on Flink runner. If you are interested in learning more about how Lyft is using the Beam on Flink runner in their environment, come join us on Thursday at 11:40. Thomas Wiese from Lyft will be co-presenting with me about Lyft's usage of the Beam runner. In addition to improvements in streaming, we also done a bunch of improvements on our server side, starting with a redefined and redesigned UI for creating jobs. We made it very simple to create single source to single sync ETL jobs. We now offer about 20 plus different ETL templates. For example, you can move data from Bigtable to GCS storage, or import data from GCS storage into BigQuery. But lots of combinations of sources and sinks you get for free when you use these templates. We developed and released a new connector for BigQuery's fast storage API. We improved our security, your security actually, our support of your security, by, for example, not requiring you to use public IPs anymore. You can use private IPs for your Dataflow workers. Very recently, we launched support for VPC service controls. This helps you preventing data exfiltration threats. And lastly, our batch customers like the fact that they can join and group hundreds of terabytes of data using the Dataflow shuffle. Let me show you a quick demo of how easy it is to create a new streaming job that dumps all of the data from a pub subtopic into GCS storage, in effect creating backups of streams, and then creating alerting for these streaming pipelines based on predefined conditions. Demo, please. All right, so I'm currently in the PubSub browser. I have a PubSub topic called transactions. And this topic has a never-ending stream of sales transactions, things like who purchased the good itself, the sale amount, the place of sale, the time of sale. So what I want to do, I want to create backups of data in this topic. And I can do it very easily now by going to several of the contextual menu options. Not only can I import, I can actually export as well. I can export into BigQuery, or I can export into cloud storage. I'm going to choose the other option, cloud storage. And within a few seconds, a new screen will pop up that will allow me to complete my flow. All of the relevant values are pre-populated. For example, the Dataflow template that implements this flow is pre-populated. There are many, many more. Just look at this list. I could have exported and backed up a Cloud Spanner database into storage, or I could have imported or exported data from Bigtable into storage. But I'll stick with my predefined template, my PubSub to text files, and just finish up typing in the name of the destination. This is the bucket where all of my PubSub transactional data will be stored. I'm going to give every file a prefix so that I don't lose it in the output bucket. And I'm also going to type the name of the temporary folder. And I will actually not forget this time to change the name of my job because I've done a couple of pre-demo prep and created several of the same job names. All right, within a second or two, Dataflow will populate the execution graph of this pipeline. It has 3 steps. The first step is reading from PubSub. Then this template will window all of my data elements in the stream into 5-minute chunks. And each of these chunks will be then stored in cloud storage. It takes a couple of minutes to populate enough data to enable my latency graphs. Let me save the time and just pop into another job that I launched before the demo. Here's how it looks after a couple of minutes. I now see that my pipeline has about a couple of seconds, 3, 4, 5 seconds of latency. Latency measures the time between when an event enters the pipeline and exits the pipeline. And I have appropriate statistics for freshness as well. So what if I want to define an alert for this pipeline where I want to get notified if the latency of my system exceeds 20 seconds? This is very easily done now by clicking on this Create Alert link, where I will be rerouted to stack driver monitoring with a bunch of values already pre-populated. I'm going to keep most of the filters the same. Yes, I want to monitor Dataflow jobs, and the metric that I want to monitor is system lag, and this filter also works for me. Job name equals my job name. What I do want to change is the threshold. So 20 seconds. Once I exceed 20 seconds, the values are in milliseconds, so I actually have to type in 20,000. So once the value reaches this value, I'm going to get an alert. And let me just save this alert. And voila, I've got an alert. I'm going to get a SMS or an email whenever my pipeline gets slow. Back to slides, please. So what else is new? There are 2 other areas where we've done good improvements, and I actually wanted to quickly explain what all of these new products mean: TensorFlow, Kubeflow pipeline, etc. We are continuing investing in our machine learning and AI support. TensorFlow Extended is open source machine learning platform for production use, kind of on a serious scale. Kubeflow is a Kubernetes-based machine learning platform. It works with TensorFlow, but it also supports other frameworks. And Kubeflow Pipelines is the technology part of Kubeflow that creates infrastructure for data processing for Kubeflow. So the things that we improved over the past 2 to 3 months is we created an integration point with Kubeflow Pipelines. So you can now do feature pre-processing using Kubeflow pipelines that will spin up a job in Dataflow. Dataflow and Beam are powering TensorFlow Extended. All of the major data processing tasks of TensorFlow Extended are running on Apache Beam, and by extension, they can run either in the Google Cloud on Dataflow, or they can run on Flink. And lastly, we keep investing in our Python support as well. For example, we recently released a Bigtable Python connector. We launched support for Python 3, and I already mentioned our streaming capabilities that we released in beta. And with this, I would like to invite Chris to talk more about Hadoop and Spark in the Google Cloud.
Thanks. Hey, everybody. I'm Christopher Crosby, and I am a product manager on our open data and analytics team. And so I'm here to talk about how Spark and Hadoop, combined with Cloud Dataproc, can help you do processing on cloud-scale data sets. So our goal with Cloud Dataproc is to let you take the open source tools, algorithms, and programming languages that you're using today, but apply them to cloud-scale data sets while at the same time helping you integrate with the rest of the Google Cloud ecosystem. So I think we've established this already, but Cloud Dataproc is Google Cloud Platform's fully managed Apache Spark and Apache Hadoop service. And while I'm saying Hadoop and Spark, it's really an open source, an engine for running open source software in that ecosystem. We offer customizable machine types, which means that if you have a set of machine learning jobs, those could live on one cluster that's very compute intensive, while at the same time you could have a set of BI or ad hoc analysis applications that live on a memory heavy cluster. The two never have to contend for resources, but they could both be pointing at, reading from, and writing the same data sets in Google Cloud Storage. And we offer you a lot of tools and features specifically designed for managing those type of architectures and ephemeral Hadoop and Spark clusters just in general. We also give you tight integration with the rest of Google Cloud Platform. So this is not just us giving you yet another cluster that you have to manage. We are going to let you run your existing open source software, but still modernize your stack. Dataproc also gives you a lot of flexibility and a lot of different knobs you can turn. Now, we do our best to create some sane defaults for those knobs, so it's really easy to just get going if you don't care. But because we do expose those knobs, we find that customers use Dataproc in a couple different ways. The first way is what we refer to as job-scoped clusters. And this is really efficient for batch and ETL type processing. In this mode, essentially what you can do is have a single command that sends a graph of jobs to Cloud Dataproc. We will spin up a right-sized cluster, run those jobs, make sure that your cluster is torn down, and then save all of that information into Stackdriver to make sure that you have a full record of everything that happened while that cluster existed. And because Cloud Dataproc can usually give you a fully loaded Hadoop cluster in around 90 seconds, this is a really effective model for starting to think about jobs and clusters as a single entity. And so customers have a lot of success with this model. And we have a lot of features like our jobs API or workflow templates or clustered schedule deletion that helps Dataproc customers with this model. Now, we also have customers that tell us they have scenarios for semi-long running Cloud Dataproc clusters. Examples of this might include things like a shared cluster for interactive or ad hoc analysis, often with web notebooks like Jupyter or Zeppelin, or BI applications built on tools like Druid. And we have plenty of features that help with this as well in Cloud Dataproc, things like our high availability mode or our autoscaler. And if you want to learn more, I actually did an article a couple months back on my top 10 tips for running long-standing Dataproc clusters. There's a webinar associated with that. So there's a lot of materials out there on the web already if you want to learn more about how to go and use Cloud Dataproc for long-standing clusters. But regardless of which model that you choose, Cloud Dataproc has some pretty big differentiation among the, compared to other cloud providers and the competition here. So with our features like auto-scaling and workflow templates, we make it really easy to manage both ephemeral and long-running clusters. We have both a high availability mode as well as strong consistency on our storage backend, which is Google Cloud Storage. And we even received external validation from an analyst firm, ESG, that Cloud Dataproc's TCO is less than half of on-prem clusters, and even 32% less than some of our cloud competition, like Amazon EMR. So just to give you a feel for some of these features, I'm going to quickly jump into a demo that's going to show off some of Dataproc's features. Actually, you can go back to, there was a video on the last slide, in the slide deck. There we go. We'll just leave it like that for now. But essentially what this demo is going to show is my motivation for this demo is that as a product manager for Google Cloud, I find I spend a lot of time writing blogs and articles that I go out and put on the web. And what I'd love to have is a machine learning model that told me, is this going to be a good article or not? Are people going to like this? And so whenever I have questions like that, the first place I always tend to go is our BigQuery public datasets program which has over 185 different public data sets that I can take and use to augment my analysis. And so the public datasets program actually had a perfect data set for my use case here. It has a Hacker News data set of every article written in Hacker News associated with a score of how well that article did on the internet. That score is a combination of upvotes as well as relinks, and there's a couple other things that go into that algorithm, but essentially it's a label that I could use for my machine learning application associated with the full text of an article. And so what I'm doing here is I'm just going to make sure I have scores greater than 0, as well as a length of text greater than 0. And that way I'm just cleaning up the data to make it a nice data set that I can process, and I'm going to take just the first 1,000 so I can better understand how to work with this data. And you can see what comes back here is a set of data that I can use to do this machine learning. Now, BigQuery is awesome for SQL, but I'd really love to take this out into Cloud Dataproc so I could do some things in R and with Spark machine learning and some other things. So what I'm going to do here is I'm just going to save this 1,000 row sample as a Hacker News sample data set, and then I'm going to jump back into Cloud Dataproc. Now, in Cloud Data, as soon as this job completes, I'm going to jump into Cloud Dataproc. Now, within Cloud Dataproc, what we do is through our component gateway, we expose the web UIs for components that are running on your cluster. So because of my Cloud IAM permissions, I can jump right into a Zeppelin notebook, which is a notebook for working with Spark. And the first thing I'm going to do here is just show you that that query I just ran in BigQuery, I could have run that directly in Zeppelin. There is an interpreter for it. But what I really want to do here is I'm going to pull that data into a Spark data frame. So I have this Python function that accepts an arbitrary table name, and I'm going to pass it my Hacker News sample. And just like that, I've now converted that BigQuery table into a Spark data frame that I can work with. And so I just want to do a quick check on the counts and double check that, yes, I do have 1,000 rows coming back. I'm good to go. And the first thing I want to do now is I'm going to, with one line of code, I'm going to take that data frame, register it as a temp table. What that lets me do is work across all of the languages of Spark, whether it be Scala, SQL, Python, R. I can now just move interchangeably between languages against that same data set just by registering that table. And you can see now I've flipped into R. And so I was in Python, now I'm using R against that same data set. And all the familiar things I would do in R with things like a quick filtering and aggregations and transformations, I can now do those on cloud scale data sets without having to learn something new. I can now, and there's two ways I can start to scale my analysis across Spark. So first of all, I could do something like a list apply in R, where I could take several models all at once with maybe different hyperparameters and send those all across Spark to all be trained, come back, and then I could pick the model that had the best hyperparameter tuning. But what I'm actually going to show here is another technique with a dapply, where I'm just going to run an NLP algorithm across that full data set. And that full data set here is only 1,000 rows, but it does give me enough of an indicator that, like, yeah, I'm on the right track with this model. I want to see how it looks if I'm trained against the full data set. So the idea here is I could send it a note of my, some text of my own and have a score for how that's going to do on the internet. So all I want to do now to train the entire model is I'm going to change my table name in the same exact notebook from sample to full. And then I'll just go ahead and I'm going to rerun that entire notebook, all that code steps you just saw, I'll just rerun that, but now on the full Hacker News data set. So as that's running, what I want to do is I'm going to flip back over to Cloud Dataproc console just so I can show you what's happening underneath the hood. So you can see I started with that whole time I was in a 3-node or a 3 VM cluster, which was totally fine for working with my 1,000 samples. But in about 2 minutes, what happened is my yarn pending memory spiked. So, and that's because I'm pulling in that BigQuery data. And so now the Dataproc autoscaler went ahead and added 2 nodes to my cluster to help me out there. But then what happens is you can see there's another spike in yarn pending memory. And so the Dataproc autoscaler has now spun up a full-size cluster to help me process that. Once the model training completes, I can simply hit refresh here just to show that the autoscaler is now going to take away those nodes because I don't need them anymore because the model training completed. And you can see where there's a spike, the memory wasn't needed anymore, and that's why the autoscaler took down those nodes for me. And finally, if I wanted to save all of this off without having to have a running cluster, but be able to retrain my model at any time, or I could hand it my next article and have it run against that article, that algorithm again, I could simply use a workflow template. And what that looks like here in the console when I go to workflow templates is I can simply click run after I've set that up, and that will spin up a right-sized cluster for me that will run those jobs and then take down that cluster. And so Cloud Dataproc, we are really trying to change open source software to be cloud native. And so this means taking features that are fast, easy, cost effective, and building around those. And so we launched more than 30 features last year alone. So this is still an area Google is heavily investing in. If you want to know more about specific features, we're going to do an entire Dataproc feature session tomorrow at 11. We'd love to see you there. But for now, I'm going to hand over to Ravi, who's going to talk about how Qubit's actually using some of these features now.
Thanks, Chris. That was a great demo. Auto-scaling in action, really good. Hi, everyone. I'm Ravi Preti. I'm the platform engineer lead at Qubit. At Qubit, our vision is to have a world where every customer can have a personal experience with the brands they love. We want to create the greatest customer experience in milliseconds. We want to, our mission is to drive customer loyalty and lifetime value through personalization. We work with enterprise customers across 3 main verticals: gaming, e-gaming, travel, and retail. In order to power these personalizations, we collect and process a lot of behavioral data. Let's have a look at some numbers. So at Qubit, we process more than 120,000 events per second at peak times. We have petabytes of data stored across thousands of BigQuery tables and other Google Cloud Storage solutions. We power more than 55 billion personalizations per month. That is around 8 per person on the planet. Google Cloud enables us to operate at that scale with ease. Let's consider a use case, a personalization use case, where a visitor is looking at a product page and you want to show some recommendations along with that product. So how do we go about it? It all starts from a user browsing through the site, looking at different categories, at different products. And as the user journeys through the site, we trigger a lot of behavioral data. We collect and process it. The architecture here shows how our pipeline would look like that solves this use case. We will revisit this architecture, but this time, step by step. We'll follow an event from the start to the end as it travels through Qubit systems, and see how we use the technologies which are relevant to this session, where Dataflow and Dataproc fit into the picture. The event that we are interested here is going to be a product event, somebody looking at a product page. The very first thing happens is a user is looking at a browser, it triggers an event or a mobile app, triggers the event, it enters Qubit via our Qubit gateway, where it's tagged with some meta information and moves forward to our very first data flow, that is the validation data flow. We internally call it the gatekeeper. As I'm talking about the first data flow in the architecture, let me share our experience with data flow, how we manage deployments and how we monitor them. Our experience with prototyping ideas with data flow has been really good. Since most of our code was in Java for the old pipeline, it was really easy for us to actually try those things out in Dataflow. Now looking at the Beam vision, obviously there is support for more languages, so I'm sure it will be easier for many of you here. We were actually able to move really fast, iterate and validate ideas really quickly. In fact, it was so easy to code and run these data flows that it almost gets you into this thinking called data flow thinking, where you almost want to solve all the problems using a data flow. It is that easy. In terms of deployment, we have our own in-house a Dataflow launcher that we use to deploy these Dataflow. It lets you seamlessly deploy Dataflows. You don't have to worry about paths. You don't have to worry about options, the plumbing code around creating pub-sub subscriptions and things like that. By the way, we have open sourced it, so if you look on GitHub, you should be able to find it. As you can see here, we also have schema registry. So obviously, in this journey, we are following the product event. But in reality, we have thousands of different events, which have their own structure, own customizations per client, and things like that. In order to manage that, we have our own web service, which is schema registry, that helps us manage those schemas. I'll quickly talk about monitoring as well. So we use a mix of Stackdriver and in-house Prometheus monitoring. We started with Stackdriver, and it works really well. It has worked really well for us. We use it for monitoring things like undelivered messages in PubSub, or what is the system lag, and things like that. But we have certain unique requirements where we are interested in not just the freshness of all the events, but actually this product event for a particular client. That's why we host our own monitoring as well. So yeah, moving on, validation data flow. It looks up the schema from the schema registry, validates it. If it's all good and legit, moves it forward to our next data flow, which is the enrichment data flow. So suppose this event, we want to know whether it was actually triggered by a browser with human interaction or whether it was a bot doing that. So things like bot detection is what we do in the enrichment data flow. We also do things like currency conversion, time zone conversion, geolocation, and things like that. Basically, it adds a bit of a golden touch to the event. We internally call it no points for guessing, but Midas. After enrichment, this event is pushed forward to our next data flow. This is the persistence data flow. The persistence data flow makes sure that this particular product event enters the right table in the right data set. As you can see, we have schema registry doing a cameo appearance again here, but this time it's responsible to give us BigQuery-specific schema that we can use to translate our product event into a table row type and look up things like meta information, like what are the partitioning columns for BigQuery and things like that. This completes our events journey, starting from the browser, traveling through our various data flows, and enters into BigQuery, our data warehousing solution. A bit of a detour here. So we at Qubit extensively use data flow in batch mode as well. One of the use cases, so just very similar to the one that we are talking about, suppose a client has an in-house generated recommendations. And what they want to do is use the Qubits one and their own, merge them together, and create more powerful personalization experiences. So here in this, as you can see, an automated system creates recommendation, pushes it into Qubit to GCS. We have services looking for these object change notifications via PubSub. We spawn on-demand data flow that reads the file, can auto-scale if the file is big, and finally pushes data through to Bigtable and to BigQuery as well. A quick note on unified programming model. We really love the unified programming model. Running the same code base in streaming mode and in batch mode is really good. You can think of use cases like suppose you have to do migration, and you want to have the same code base. So currently, if it's reading for PubSub, but you want to migrate data from, let's say, you have Kafka queue running to your new pipeline, all you have to do is just switch the sources around. So yeah, as of now we have covered the first part of the architecture, which is our real-time streaming pipeline, where events has, it's all happy and good in the BigQuery. Now we'll move on and do something useful from that event. So this brings in Dataproc into the picture. So our recommendation workflow, this is how it looks like. Basically, that product event, we look at some of the interesting things from that event. What are, let's say, some attributes like, was it a blue color shirt? Which category did that product belong to? And things like that. Things that are required for our recommendation algorithms. We do that feature extraction. We prepare the input for our recommendation algorithms and put it on GCS. Next up, we spawn on-demand Dataproc clusters, submit these Spark jobs, and produce the recommendations, which are now ready to be consumed by our rec service. So now, as we can see, we have sort of completed our journey where a product from the browser entered BigQuery, we generated some recommendations out of it, it is back on that page. So we've completed the whole cycle. As I was talking about creating these on-demand cluster, as we have more and more clients coming in, more and more recommendation algorithms given by the data science team, we were spawning lots and lots of on-demand Dataproc clusters. In fact, we had thousands of Dataproc clusters running in a day, or spawning and running in a day. We have also, one thing, if you follow that approach of actually creating on-demand clusters, two things that I'll mention is, first of all, as I said, the scale that we have used in, so in case you had that doubt in your mind, what if we have to create thousands of these clusters, we have used it in production for a long time now, so it should work for you. The second important thing is, if you do go with that approach, do have a look at scheduled cluster deletion, because sometimes if for some reason your jobs are stuck and you have these clusters being spawned, you probably don't want to make your bill go high and waste resources. Currently, we are also experimenting with using long-lived clusters with auto-scaling turned on, so we can use the on-demand clusters and a single cluster in tandem. In conclusion, fast prototyping. It's really easy to prototype and validate your ideas in both of these systems. So if you're thinking about it, I would recommend just go for it and see it for yourself. Serverless makes our life really easy. Auto-scaling, gives you that peace of mind, whether it's peak time or off-peak time, it's gonna, manage the resources efficiently. New features. Google has been great in launching new features. And as they launch new features, we retire our code, and we love that. Who doesn't really love, just removing old code that you don't need to use anymore? Last, there are a lot of online resources that you can look up. There's a wealth of resource out there. For example, writing Dataflow pipelines with scalability in mind by Ruben. There are a lot of blog posts actually written by Sergey as well, so you should have a look. In total, all these things have made our life easy. We can focus on creating new things rather than maintaining systems and worrying about days like Black Friday or Boxing Day. And we at Qubit can now focus more on our vision where every customer has a personal experience with the brands they love. On that note, I'm going to hand it over to Sergey.
Thanks, Ravi. All right, let's wrap up. Have a couple of announcements at the end. We also have time for questions. We have 5 minutes for questions. Please start lining up at the microphones. We would be happy to answer them. Nope, not yet. So Dataflow. Hopefully I was able to show how Dataflow continues investing into streaming, makes it really easy to work with batch processing, is open and scales resources and optimizes your time processing. Dataproc is an easy, fast, cost-effective way to run open source software in the GCP cloud. If you would like to learn more about Dataflow and Dataproc, come to these sessions on Wednesday and Thursday. We'd be happy to share more. I also have an announcement to make. A small one. If you would like to learn more about streaming systems, you can buy a book and get it signed by the members of the Dataflow team who wrote the book on streaming systems. They'll be here on Thursday at 1 p.m.